Good morning, boys and girls. We are back for another day here. Section 2.4, Infinite Limits. Alright, so we've kind of done the first few days of limits now, and we should have a pretty good feel for them. Today we are going to look at this limit here. The limit as x approaches 0 of 1 over x. We're going to start by looking at the one-sided limit, as limit as x approaches 0 from the left, and the limit as x approaches 0 from the right. Just to kind of review a little bit, we really have a few different ways that we can evaluate limits, right? One of those ways is numerically. We could create a table and plug in values that are close to 0 from the left. So like negative 0.1, negative 0.01, negative 0.001. Or I could, if I'm doing it from the right, I could plug in numbers like 0.01, 0.001, 0.001. I could make a table with those values. And so that's the way I could try to figure this limit out numerically. We've talked about doing it algebraically, where I could, try things like, I'm just going to plug in, and if I get, in this case, I get 1 over 0, so that's undefined. So we're going to talk about kind of what that means in a second. But we talked about if I got like 0 over 0, then I could do things like factoring, or try to simplify my fraction, or I could use the conjugate, so that we could solve this algebraically. We also have graphically, okay, as a way that we can do this, and that's how we're going to start out with this one. We're going to attack this one graphically here in a second, and talk about what's going on. And then we're going to add one more way today, our fourth way of doing limits, and that's analytically, okay. And that means that we're just going to kind of think about things, about what's going on with our limit, and try to evaluate that way. So those are the 4 ways we have of really evaluating limits: numerically, algebraically, graphically, and analytically. Okay, but we're going to try to do this one graphically. Hopefully we all remember what the graph of 1 over x looks like. All right. If not, it looks something kind of like this. On this side, it's kind of going up and down in that quadrant there. And on this side, it's kind of going along this quadrant here. And in the middle, like remember here and here and here, there's an asymptote here, a vertical asymptote, and a horizontal asymptote right there. Okay, that's what the graph of 1 over x looks like. Just quickly sketched. So now, if I look at the limit as x approaches 0 from the left, as I'm approaching, oh man, I realized yesterday it's kind of hard. I'd like to point with my pen, but you can't see when I point with my pen. So maybe I got to do this. I'm learning things every day about this. So I'm looking right here at this piece right here. As I approach 0 from the left, I'm kind of looking like right there. Okay. It looks like the graph is approaching negative infinity. Right? It's getting smaller and smaller and smaller. I'm not approaching a single y value. As I go in there, I'm getting closer and closer to the y-axis, and I'm going down and down forever. So I'm not quite getting a single value. I'm going to negative infinity. Going back to this in the first place, we said talking about plugging in. If I just plugged into this, I'm going to get 1 over 0. 1 over 0 is undefined. And so since that's technically undefined, this whole limit really does not exist. I could say that it does not exist. However, when we're looking at this one-sided limit, okay, as I'm looking at this one-sided limit, I could say, if I did this, I could say that it does not exist because I'm not approaching a single value, but we kind of can use our limits to describe what's happening graphically with our functions. So because, as I'm coming here, because it's going to negative infinity, we also say that this is approaching negative infinity, or that it's negative infinity. Same thing as I'm approaching 0 from the right-hand side. Okay? If I look at the next one here. For this guy right here. As I'm approaching 0 from the right-hand side, same idea now. We are approaching a positive infinity. On a multiple choice part of your test, you might see either answer. Okay? They might say that this limit is infinity, or they might say that the limit does not exist. Either answer technically is correct. You could put either one. They won't ever have both, but they might have either one. So know that this limit either does not exist or approaches infinity. For tonight's homework and for the purpose of this lesson, please don't put does not exist on anything, on everything, because you're not going to get what you need out of this lesson. Please try to get to this infinite and negative infinity answer. However, when we go over here to our two-sided limit, because the limit from the left and the limit from the right do not agree from each other, from the left I'm going to negative infinity, from the right I'm going to positive infinity, because those don't agree with each other, this would have to be does not exist. I'm getting out of your review there. Does not exist. Okay? So, the double-sided limit has to be does not exist, but those single-sided ones I can put infinity or not infinity. If, for some reason, like my graphs both went to infinity, now because they agree, for the two-sided limit, I could put infinity. Okay? So that's a quick little review of, or not review, I guess a quick little introduction to infinite limits right there. Alright? I'm going to pause while I set up our first example we're going to do. Okay, here's our first example all set up for us. Again, if you need to, just like I did, you can pause the video so that you can copy down our illustration here on the graph that we're working from. But again, to keep these things short and halfway entertaining, I didn't want to bore you with my drawing of this thing. Alright, so let's look at this. We're going to look at the limit as x approaches -2 from the left-hand side. Okay, so we're kind of looking at this piece. Again, you can't see what I'm doing that. I'm kind of looking at this piece right here. So the limit as x approaches -2 from the left-hand side. Again, I could say that does not exist. Or if I want to describe or indicate better what's going on with our graph, we might also say that this is going to negative infinity. And I'm going to say that that is the better answer for tonight's homework. Please try to get to that answer. Okay, don't just say does not exist. On a test, if it's true response, I would accept either one. And again, on a multiple choice, you might have to find either one, but they would not have both. Alright, if I'm looking at as x approaches -2 from the right-hand side, that would be that part of the graph right there. And so again, this is going to negative infinity. If I look at the limit as x approaches -2 of h of x, then the two-sided limit from both sides, because these are both going to negative infinity, then I'm allowed to put, or I'm able to put, negative infinity. Okay? I don't know if you want to pause the video right now for a quick 10 seconds or so and do the next 3 on your own and try them. Give yourself a little test. I would highly suggest doing that, and then you can kind of check yourself. So I'm going to pause for a second so you can pause, but then I'm going to continue on. Okay, welcome back. If you were to do the limit as x approaches 3 from the left, this is going to go to infinity. That's this piece right there. The limit as x approaches 3 from the right-hand side would be that piece right there. So that is going to negative infinity. So the two-sided limit, the limit as x approaches 3 of h of x, because those two things do not agree, this has to be does not exist. I'm betting you guys all aced that with flying colors. Nice job. Alright, here we move on to our next problem. Okay, here we are, number 2. So on this one, again, we want to evaluate the limit as x approaches 4 of x minus 5 over x minus 4 quantity squared. So if I wanted to do that limit, I would really need to look, again, that's a two-sided limit. So I would need to, really our goal, should start doing this because you can't see what I'm talking about. We're trying to evaluate this limit down here. So I really need to look at the two-sided limit up above. The one from the right and the one from the left. Okay? My right-hand-sided and my left-hand-sided limit. Now, again, if we just gave you this limit down here, this guy here, we said normally you're going to try to approach this thing algebraically, I would say. And so we, talked about first you're going to try direct substitution. And I'm going to plug in. If I plug in, I get 4 minus 5 on top, which is -1. And then if I plug in on the bottom, I get 4 minus 4, which is 0 squared, which is 0. So again, technically, that is undefined, so the limit does not exist. Again, we could totally say the limit does not exist. But we're going to try to be more specific to describe what's going on. If we think graphically here, because we have this x minus 4 on the bottom, we know that's going to create a vertical asymptote. So as we run along this vertical asymptote, maybe we're going to go to infinity or negative infinity. When we have the vertical asymptotes, that's where we get these infinite limits. Okay? So instead of having to draw this thing out, again, oftentimes drawing this out is difficult. What we want to do is we are going to just kind of approach this, we say, analytically. I'm going to kind of think about what's happening, okay? So it's kind of a mix between direct substitution and I'm going to think about what's going on. I'm going to start with this top one here. The limit as x approaches 4 from the right. If I were to kind of plug into this thing, on top, if I were to plug in the 4, this is kind of what I'm thinking in my head, but I'm going to write it so you can see it. If I were to plug in 4, I would get -1 on top. So that's not a big deal, kind of like we talked about down below. On the bottom, again, I don't want to just plug in 4 because that's going to give me 0 and lead us to this conundrum down here. I want to think about as I'm approaching 4 from the right. If I'm approaching 4 from the right, I'm going to plug in numbers that are bigger than 4. Like, again, 4.0, 4.01, 4.001, 4.1, numbers of that effect. Okay? So I want to think about those numbers in my head. And if I do that, 4.1 minus 4 is like 0.1. 4.01 minus 4 is like 0.01. And then if I square that number, if I square a decimal, a small decimal, it's going to make an even smaller decimal. So when I plug in these numbers that are really, really close to 4, I'm going to get some small, because I'm squaring it, positive number. That makes sense. That's what I'm kind of thinking in my head. -1, if I plug in like 4.1 or 4.01, it's going to be some small positive number. So if I take -1 and then divide it by that small positive number, if you take any constant and divide it by a really, really small number, that is going to give you a large number. So that tells me that, that tells me that this is going to go to -infinity. Okay? Kind of the same thing here. If I do 4 from the left-hand side, on top I would just plug in the 4, and so I get -1. On the bottom, I would plug in numbers that are smaller than 4, so like 3.9, 3.999, 3.999. So when I do that, I would get some negative number, some really small negative number. But then when I square that small negative number, I'm going to end up with a small positive number again. So again, in this case, I'm going to go to -infinity. And then, now I can look at this two-sided limit, because from the left I go to -infinity, and from the right I go to -infinity. Then this two-sided one, I can actually say that they both are going to go to -infinity. Okay? I hope that makes sense. It's analyzing and thinking about things and looking at it analytically. Okay, so here's one more example of we're gonna approach things analytically here in a second. Again, if I just gave you this limit to evaluate, again, the first thing you should do is plug in. If I plug in here, I'm gonna get 1 minus 5 is -4 plus 6 is 2 over 0. So again, I could say that this is undefined or the limit does not exist. However, we're gonna try to be more specific a little bit. So we might try factoring, but if you factor, nothing kills off in this case. This is not one of those indeterminate situations, although you can factor that top. So I just want to think things, because I got that undefined, because I know I've got this vertical asymptote. I just want to think about what's going on. So again, if I plug the 1 in the top, we said you're going to get, where'd my pen go? I'm going to get, we said 1 minus 5 is -4 plus 6 is 2 on top, right? Now on the bottom, again, I'm going to plug in numbers. We're coming from the right, so numbers bigger than 1. So I'm going to plug in, like I'm thinking in my head, 1.1, 1.01. If I do that, again, what that's going to give me on the bottom is, in this case, again, some small positive number is what I'm thinking. And then again, any constant divided by a small positive number is going to be infinity. Okay? So that I could now say that, again, this limit is going to be infinity. So that pretty much sums up everything for today, boys and girls. I hope this gives you a good idea of infinite limits. You can now go ahead and try the homework. And again, if you have any questions, please contact me, and I will see you all real soon.